All right, guys, a little bit more review for your assessment that's coming up on this Thursday uh, is going to be going from factored form to standard form, or standard form to factored form, or standard to vertex, or going from graph to the other ways. So we're going to do two examples. We'll do one given standard, sort of going from this algebraic to the different forms and to the graph. And then we're going to come back here. This one's on page 54 in your packet. We're going to go from the graph to the forms, so a little bit backwards. Okay, so we get this 1x squared minus x plus, minus 12. So we're going to go to vertex form here because we haven't done a lot of completing the square where we just have a 1 as our center term. It kind of makes some things a little messy because we're going to have fractions. So vertex form is when we're making squares. The operation is called completing the square, and so we're going to make a square. So x squared creates only one square. Negative 1 is going to be broken up evenly, hence a square. So half of negative 1 would be negative 1/2, and negative 1/2. Well, if I had a square, this component right here would have been made by taking x minus 1/2 by x minus 1/2 and getting whatever this little piece of the box is right here. 1/2 times 1/2 is 1/4, whether they're both positive or they're both negative. So in order for this to be a square, this would have to be positive 1/4. Well, we think back to our quilt blocks. I was already 12 1 by 1 blocks short of what I needed to be. So if I needed 1/4 to make a square, I didn't even have any to begin with. Now I'm even shorter than that. I'm 1/4 more short from 12. So that means that I am now 12 1/4 short. We note that as the minus. And then the box as a square is x minus 1/2 by x minus 1/2, which we note as a square. So this is our vertex form. Now let's imagine we want to go to factored form. Factored form, we've done factoring before. We do that AC method. 1 times negative 12 gives us negative 12. What two numbers multiply together to make negative 12, but add together to make negative 1? Well, our options are 1 and 12, 2 and 6, 3 and 4. And they need to be negative. So one has to be positive and one has to be negative. The only ones that would make possibly a negative 1 would be this grouping, and that would be if 3 was positive and 4 was negative. So factored form creates rectangles. Vertex form creates squares when you're thinking about this visually. So I know what these two components are here, so I'm going to have x squared, negative 12, 3x, and negative 4x. So this is what the dimensions create when I multiply them together. Now I just need to figure out what the dimensions of the box are. So x by x would give me x squared. X times 3 gives me 3x. X times negative 4 gives me negative 4x. So factored form is when you're highlighting the dimensions of a rectangular box that create this area. X plus 3 by x minus 4. So we have our vertex form, our standard form, and our factored form, which give us all of the key features we would possibly need to graph this. So I'm going to go ahead and put my axes on the graph, kind of make them dark here. So it's not going to be perfect, but we'll still be able to make a sketch. So 3 and negative 4 are these terms right here. So what would x have to be to make this equal 0? X would have to be negative 3, or if x were positive 4, we would get y equals 0. So I'm going to go ahead and plot those on there. And then I'm going to take my vertex form and pull the vertex out of that. The vertex would be at positive 1/2 from the opposite of this, negative 12 1/4 from exactly what this is. So it would be right in here, and then we're going to come down, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, we'll go ahead and count down, 10, 11, 12, and 1/4 is just, we'll just say just a smidge there. And then standard form here is going to highlight our y-intercept, which is going to be at negative 12. So right here. And then I just take all that information, my 3, 4 points that I have here, and I'm going to graph through them. So from the roots to the y-intercept to the vertex. And then back up the other way. Okay. So there's one example given the forms going to the graph. We're going to go the other way now. We're going to go from the graph to the forms. So let's imagine, I've got this graph here. I'm going to give you guys what the points are because it's kind of hard to read on the graphs. Let's say that this is the point, the only point we've got right now is that the vertex is at x equals 2, y equals negative 3. So the vertex form of this equation is going to be something times x minus 2 squared minus 3. We still have to find the growth factor here. So let's find a point that looks like it's right on. We're going to say that it's this one. Imagine I gave you this point too. This is the point negative 2, comma 5. So given negative 2, comma 5, I can figure out what my a is by saying I know x, I know a y, so let's plug those in for x and y and figure out what a would have to be. Let's plug those in. 5 from this. Negative 2 goes here. And then I'm going to go through it operationally. A times negative 2 minus 2 squared minus 3. So 5 equals a. This becomes negative 4 when you work through it all. Negative 4 squared is 16 minus 3. So we add our 3 over. Add our 3 over. And now we've got 8 equals, we're going to rewrite this as 16 times a, so it looks a little bit more friendly. And when I divide 16 out, I get a equals 1/2. So I could come back up here and say that it's times 1/2. So I've got my vertex form. Standard form. How do I go from standard form? How do I go to standard form from vertex? I'm going to walk through this one time with you guys. So I'm going to take this square and I'm going to mark it up. So x minus 2 squared means I have a box that's x minus 2 by x minus 2, which gives me x squared, 2x negative, positive 4. Here's the thing you want to be careful of though. We have a half of these. So algebraically we're going to want to take care of that. So we have 1/2 times x squared. These two are going to come together to make negative 4x minus 4x, and then plus 4, and then don't forget me, minus 3. So now I have 1/2 x squared, I'm just distributing here, minus 2x plus 2 minus 3. Okay, so I have 1/2 x squared minus 2x, I've got common terms here and here, makes minus 1. So my standard form is here. So this equals y, and that's standard form. and then I can check to make sure it makes sense. Does my y-intercept look like it's at about -1? It sure does, right about there. So it looks like it checks out. If I wanted to, I could then factor this by doing the AC method, but because this is 1/2 times -1, you're probably not going to get something that factors cleanly into either into integers or even into rational numbers. So we're going to go through later, how do I figure out my roots when they're not whole numbers, or when they're not even fractions, when they're something like the square root of 5, how do I figure that out? But for now, we're not working on that. All we're working on is how to go from vertex form to standard form, and how to go from a graph to vertex form. Later date, we'll go further.